Assalamu alaikum, my dear students. I hope all of you are fine and doing well. So, topic here we are going to discuss it is the properties of the hydrogen halides. So, hydrogen halides are basically the compounds when there is a reaction between hydrogen and the halogens. When they are going to react, they will form the compounds. These compounds are called as hydrogen halides. And here we have four types of the hydrogen halide. The first one is HF, hydrogen fluoride. The second is hydrogen chloride or hydrochloric acid. The third one is hydrogen bromide as HBr, and the fourth one is hydrogen iodide, HI. So the melting point of the hydrogen fluoride is minus 83.8, that of HCl is minus 114.2 degrees Celsius, and HBr minus 86, and that of hydrogen iodide is minus 50. It means when we move from top to bottom in the group, there is an increase in the melting point. After the melting point, we have its boiling point. First one is 19.5 and the last one is minus 35.3. So there is a decrease in the boiling point when we move from top to bottom. There is a heat of fusion at melting point, that is in kilojoules per mole, 4.58 to 2.87. There is also decrease in heat of fusion. Then we have heat of vaporization that just happened at boiling point in kilojoules per mole. The heat of vaporization for HF is 30.3 and that of hydrogen iodide is 19.7 kilojoule per mole. And after this we have heat of formation, that is per kilojoule per mole delta HF. For HF it is minus 270, minus 92 for HCl, and last one hydrogen iodide it is plus 26. So there is an increase in the heat of formation for hydrogen halides. Then we have their bond energy given in kilojoule per mole. For HF it is 566 and that of hydrogen iodide is 299. It means the bond that exists between HF it is the strongest bond, and the bond between hydrogen iodide it is the weakest bond. And then we have the HX bond length, that is in picometer. The bond length between HF is 92 picometer, HCl 128, HBr 141, and that of hydrogen iodide is 166. So there is an increase in the bond length between the hydrogen halide when we move from top to bottom in the group. The last one is dissociation into its elements at 1000 degrees Celsius. Its percentage is 0%. Bond is too much strong. The HCl as 0.014, the HBr is zero point 0.5, and that of hydrogen iodide is 33% at 100 degrees Celsius. So the dissociation of the hydrogen halide it is going to be increased when we move from top to bottom in the group in the formation of the hydrogen halide from HF to HI. After this, there we have some properties of the HF, in which HF it is a colorless liquid with a strong irritating odor. So it is having a strong irritating odor as well as a colorless liquid. On the other hand, it is very strong corrosive inorganic acid. So it is corrosive acid. It is non-flammable, that it do not catches the fire but is very soluble in water. The pure HF has boiling point approximately 65 degrees Celsius, that is 18 degrees Celsius when it is in not pure form. When it is 49% by weight, then its boiling point is 220 Fahrenheit and 104 degrees Celsius. Then when it is for 49 weight, HF has its freezing point minus 35 Fahrenheit and minus 37 degree Celsius. The vapor pressure of the HF it is 7 millimeters of the mercury, that can be written as 7 mm of the mercury. Then for 49 weight by percent at standard temperature and pressure, which is at STP, the standard temperature and pressure is 25 degrees Celsius and the pressure is 1 atm, or 1 atm is equal to 760 millimeter of mercury. So over there its vapor pressure is 7 millimeter of mercury, which is very low. Then we have properties of the HCl. The HCl it is Having its formula HCl, hydrogen and chlorine, it releases hydrogen ions upon dissociation. Its taste is sour. It can corrode the metals. It means it just rust out the metals, or it just help to corrode the metals in one way or other way. It just used to neutralize the bases. For example, if we have a base and we just add up HCl, then this process or this formulation or this reaction is known as the neutralization reaction. Its pH is around of 0 to 6, and it turns the blue litmus paper to red, as it is also a strong acid, so that's why it can turn the blue litmus paper into the red color. This is used for the identification of the acids. Then we have properties of the HBr, which is hydrogen bromide, or known as the hydrobromic acid, H positive and Br negative. Hydrogen bromide is an inorganic compound that is having the chemical formula HBr. It is a chemical compound which is formed by combining hydrogen and bromine as H2 plus Br2. Then there is a formation of HBr, and the temperature is around of 200 to 400 degrees Celsius. So temperature here is 200 to 400 degrees Celsius. By the distillation of the solution of the sodium bromide or the potassium bromide with phosphoric acid or the sulfuric acid, both these methods can be used for this preparation. On the other hand, it is important in producing inorganic and organic bromine compounds. So HCl can be, or HBr, it can be also used as a laboratory reagent, and that reagent can be helpful for the production of the many compounds. And the last one is hydrogen iodide. It is called as hydrogen iodide or hydrogen iodic acid. It is a strong reducing agent, and it is used in many redox reactions in which the hydrogen halides are oxidized to elemental halogens. For example, here we have hydrogen iodide. On reacting with the sulfur, as this hydrogen iodide, it just lose the hydrogen, and the sulfur, it is just gaining the electron or gaining the hydrogen. So that's why it get reduced, and iodine just oxidized itself by losing the hydrogen in this chemical reaction. At the last, we have the reducing powers of the hydrogen halide, in which HF is having lowest reducing power because it loses the hydrogen with very difficulty. On the other hand, HCl is more oxidizing as reducing as compared to the HF, and HBr is having more as compared to HCl, and HI is having highest reducing power as compared to the all other hydrogen halide. So this was all about today's lecture. I hope you guys understand. And if you have any queries, you may ask me about that in a comment section, and I will get back to you guys soon. The next topic that we will discuss, it is the oxides of halogens. For that time, you guys keep learning and have a good day.